Okay, so today we're going to be talking about classes and privacy. The idea behind classes. So, what you guys have done in the past is you've been working with individual pieces of data. These pieces of data let you keep track of really anything that you can abstract. But the main point is that they allow you to manipulate these things and control kind of how a program flows based on dynamic changes that may or may not occur. Things like a user, things like random generation. But the issue with these individual pieces of data is that while they work for very small scale things, such as a single console program that asks a question and needs an answer, in the same vein, they don't have the ability to do anything with large scale things. Like, for instance, if you had a game and you had an enemy, and you had this enemy and they exist in several places throughout your game, writing code for each one of those possible enemies with a bunch of if-else statements would pretty much become unreadable and unmaintainable by the time you reach like the fifth enemy. So this is where classes come in. Classes are they're a template. They are a way for you to put pieces of data that you commonly use with each other, excuse me, in one place. They allow you to keep basically like running tally of um, a better way to put it would be that a class allows you to abstract a more complex object than just a single piece, if that makes sense. Like in this instance, in the class of a player, you might have an int for health and an int for mana and an int for armor, and then do some math on these based on things that happen in the game. But once you go into multiplayer, those same things you want to do each time. If they have this armor, it affects their health this way. If they have this mana, they can use these spells. But you don't want to have that same thing written out for each individual person, for each individual player that's possibly there. So, this is where classes come in. We use classes as a way to reduce the amount of logic you have to deal with. The thing there is, when you're doing these assignments, these small little things, you don't really think about how things scale up. You don't think about how things happen when you have a bug and you need to fix it. Instead, you end up in this position where you just sort of realize, you just sort of think like, oh, well, I could have done this like this, and it would have been much less code to write. Why wouldn't I just do it? Um, Classes are going to exacerbate that issue. You need to think more in lines of like, if I had 1,000 or 1,000,000 of these things, how would I then approach it? And ways to reduce down logic and how you parse data is what really makes your code easy to read and easy to maintain and easy to grow. Um, it wouldn't really be feasible, although it is technically possible, for a game like World of Warcraft to exist without the use of things like classes and data structures. If they could technically use just one big algorithm that knows every possible thing of every possible player, but that type of strategy doesn't end up working out very well. So let's get into how to make them. The first step is making a separate file. This is something that not a lot of people do, or not a lot of people have done up until this point. But a separate file allows you to quickly flip between areas that you have big blocks of logic. Your CS file, your C# file, the way that you help keep things named correctly and keep relevant things in relevant spaces is with something called a namespace. I'll just show you real quick how to do that. In fact, you'll see one here. It's called testing, and your program starts off with pretty much whatever you name your project. So let's make a new class. This is different for each IDE. You don't even need to go to the IDE to do this. I recommend you do. So let's name this one player. It did it for me, but the key part here is it fills out namespace for me. The namespace allows this program, which is this class, which is also in the namespace testing, to access pieces of player. This is a public class. I could probably do something like this. Player. And what this lets us do is now this class that I've made here in the namespace testing is accessible here. If I were to change this to something else, now program has an error. It doesn't know what player means. It wants to try to import a new namespace. Now it has to pull that in, and this is sometimes good. Sometimes you want this separation, but this sort of thing is how this is why we use namespaces. The second part is declaring a class. It's pretty easy. Privacy level, followed by the word class, followed by the name of the class. Most IDEs make classes green unless you're not using dark mode, in which case switch to an IDE that uses green and also a dark mode. The public level, the privacy level, we'll get into later, but the large majority of your time, your classes are going to be public. Filling out the class. This is one slide for what is the majority of what a class means. Basically, when you make a class, when you take, let's take player for example. Player is not just meant to hold data, it's meant to represent mentally how we would use that data. What it's supposed to do for our use case, for our game, for our program. So for this hypothetical thing, let's stick with the slides. Let's say that a player can battle other things in the game, so it's going to need health. It also can cast spells, so we'll say mana. And then I like to add an armor because you can see how this works later on, and it adds some cool things. So let's give it armor. So now the player has these three variables. This player, this Bob, if I go, I break into this, and we highlight Bob after he's initialized, we can see he has armor, health, and mana. These three things exist in Bob and are independent of all other versions of health, armor, and mana. If we go through Bob 2, he also has his own. They look the same because I haven't changed them yet, but this is kind of the whole point. It's a simple data structure. Oh, and the other part is functions. So in this example, I'll rewrite something similar. Taking damage does something with your member variables. If you have health and you take some damage, the health minus equals the damage. In this part, I did minus the armor value, so that way armor is useful. Your it'll do some logic based on when you take damage. In this part, I just said console.write you died, but maybe I call another class called game manager, and I say game manager dot kill player, and then pass it this player. The idea here is that every time a player will take lethal damage, it'll die. Even if I don't know when that's going to be, I can just sort of store it on a per player basis. And now I don't have to write code that's like, if player 1 health is 0, player 1 dot die. If player 2 health is 0, player 2 dot die. This sort of encapsulation of logic inside of a single structure takes care of that for us. So this is the other part of member variables. Oh, I didn't really touch on it. Member variables and member functions. They are the name of things that belong to a class. Variables on their own can just exist, nothing associated to them, they're just a piece of data. Member variables belong to a class. They're independent of other member variables. They exist solely within these instances. Constructors. Now, constructor is a weird way to write a function because it doesn't have a return type. It doesn't have a name. The way you do it is you write public or private, usually public though, player, in this case because of the class name, followed by 2 parentheses if we don't want to take parameters, or put in some parameters if we do. And this tells the program what to do when it does the new player. So in this case, stop this. When it says player Bob equals new player, essentially, and I'll actually show you this, it's going to call a constructor. Right now there isn't one, so just everything's default. But let's make one. Let's do public player, no arguments, health is equal to 10, mana is equal to also 10, armor equal to 1. Excuse me, is equal to 1. And then let's also write right. Now, let's run this again. I won't actually put this there, I'll put this here. Run it. And you can see, if we go through the stack trace, it goes through here, it tries to run the Bob. Actually, that'll be easier to show you if I go through it like this. Run it through this. Player Bob, and then if I skip to the next line, you'll see it gets caught in the constructor, and now it writes all of Bob's data out. Easy peasy. I'll actually put it up here so you can see it. Now we go down here, and Bob now has initialized values. Same thing, we go into here. Health is 0, mana is 0, and armor is also 0 until we initialize them. So this allows us to put in some logic for how a class might get instantiated. And this is really useful when you start having more complex classes with data that you need a certain way. You can set it that certain way at the beginning before anything else touches it. The other way to do this is with arguments. We can make another version of the constructor, and you can have both at the same time, where it takes in some arguments similar to a function. So what this does is now if we were to, instead of just saying new player like this, we can new player, and then we'll input some variables. So let's say Sarah has 13 health, only 5 mana, and 2 armor. And now we get to Sarah. You see that it's giving those variables in. Go back up to this, you see it's trying to do the Sarah piece. And also, I don't think I put in write a line, so it won't write a line. Go to console, there's only 2 sections where it says that. Moving on, we have instantiation. You guys have kind of seen this, but instantiation is how you take that template and make a version of it. Using the keyword new tells C#/your computer to gather some space and RAM, and it figures it out based on how you made your class, and then it will create a piece of it, an actual version of that template. If you have like a PowerPoint template, it'd be the same as creating the actual presentation. The usage of members. Okay, so this is actually something that you haven't seen yet. The way that you use member variables, the way that you actually access that data inside of a player, or the functions, is by using the period. Use, instance, period, information. And this allows you to only do stuff for one version of the player. So let's do quickly a take damage. This will be public void and for sake of keeping it brief in the video, the example project you can find as well, which has better versions. Let's just say and now, if we want, we can say Bob, take some damage. Sarah, you take some damage too. Let's do this. So Bob's health, if we remember, we started it off, and it starts off with, I think, 10. Yeah. So Bob has 10. Oh, that's right, because he only took 1 damage. Instead, let's say 5 damage. Now Bob's health should be 6. Yep, because it dealt 5, and then he had 1 armor, so it blocked one of it. And then Sarah, same thing. She has better armor, so she ends up going from 13 down to 10. And you can see how this sort of logic that we've made, this sort of function that uses common pieces of data, we can very easily do something like players take your damage because an AoE hits them, but they all have different armor because they bought different equipment. So now their different armor affects them differently, and we don't have to care about that at all. We've already decided how armor works, and we don't have to check their armor when we're dealing their damage. We've established how they take damage already. The inheritance and privacy. So this is the part that can be confusing for some people. This slide is a good note to reference a lot. I remember this one, but I'll just describe it myself. So we've got 3 levels. The 2 main ones are public and private. Public, anything can access it. Any program that has access to that class can access its variables that are public, or its functions that are public. The way that these work, the reason that these exist, is because a lot of times, even if you don't want all the data accessible, you want ways for things to interact with it, and you can limit those ways, and that's what public does. It allows you to decide how that works. Private is the opposite. Nothing but itself can access it. Useful for things like, oh, I want this function. I made this function that's useful for armor calculation because we have to do a lot of math, but it's only useful for taking damage. So instead of making it public, I just made that utility function private. No other class will ever see it. It'll never be relevant, but I can use it in the class all I want. Then protected. Protected is it's a tricky one. It's private for external things, but it's public for things. Really, there's not a great pattern. It's sometimes public, sometimes private. The biggest thing, the one that you need to care about, is children classes, which I will show you in just a sec. But a children class can access protected things. A child class cannot access private things, even though it technically has its own version. It'll always use the parents' version of that, and it can never affect it. Protected breaks that rule. It lets children touch it without letting everybody else touch it. So let's show you some inheritance. As you can see, we have our player class, and then over here we have another class, mage, that this the colon we use to inherit from another class. So let's go ahead and make a mage here. Class mage. And instead of it being by itself, we're going to say inherit from player. Now, player, mage has everything that a player has. This player has its health, mana, and armor. It has the ability to take damage. And in fact, I'll show you that. Oh, we'll do this. Mage. Jim Bob equals mage. Okay. Oh, what's that? Oh, we have to make a different constructor. Okay, I'll do it later. The mage now can do stuff the same that the player can. Jim Bob dot take damage, and it will do the same calculation. The useful part of this is not just that you can easily gather large pieces of data, like I want this to work for all players, but I only want mages to be able to cast spells. Let's make these all protected, so we can access them inside the mage class. So now the mage has access to this. Let's say casting a spell. Seal. And it'll always work the same way. Yep. Mana, is greater than 0, then mana minus minus health plus plus. And now Jim Bob can take some damage, and then we can also cast heal. Notice how Bob can't cast heal. That doesn't exist. Players don't have the ability to cast heal. Only mages do. So this is a basic form of inheritance. The other really cool aspect of inheritance is that any child can actually be used as though it was its parent. And the reason why this works is because the child of a parent is guaranteed to have everything the parent has. If it overrides something, it still exists. It can still be called by the other parts of the program, even if it works differently. It's not guaranteed the other way. A player doesn't have the ability to cast heal. I can't say like mass AoE and then give it a bunch of mages that they're gonna cast heal on themselves, and then give it a player because that player can't heal. But I could do the reverse, where I say everyone in this group take damage and pass it mages, even if they're not normal players, because mages have to take damage from their player. I'll show you an example of this. Let's do Void. AoE damage. He'll take an array of players. Or array of length. Take damage. Everyone takes 1 damage. And now I can be like array, and then give it Jim Bob, Sarah, and then what matters. So then I can say, AoE damage all the players. And if I run this, put a breakpoint here, run it. You'll see Jim Bob took damage even though he's not a player. He went down. Presumably everybody else also did. Sarah did not because she has hella armor. And that's called polymorphism. I think there's a slide on that actually. Yep, that's the next and last slide. Polymorphism, in addition to inheritance, you can do what I just showed you. They can exist as versions of their parent because the parent's guaranteed to work as a child. Or the child's guaranteed to work as a parent. So that is kind of short. And that's because classes are not complicated logically, but they can get confusing with syntax. So what I've done is instead of normal, where I would just tell you an assignment, instead this assignment has a starting project. I'll go through this. Create a it's called a dynarray class capable of containing an array of ints at all times and able to add to that array as needed, because normally arrays you can't add or take away from. They should start with the size of 1 and the data be uninitialized. Uninitialized data is always -1. My tests will never give you negative numbers. So if you have a -1, it means it's uninitialized. When the array needs to grow to add more ints, double its size. So that way it has more uninitialized data and then can replace some of that uninitialized data with the data that you're adding to it. It should be capable of returning the data array, meaning the stuff that we've added to it, but also the pure array, which is both the stuff we added and all of the negative ones. Sometimes they're the same, in very few cases, but sometimes they are. It should be able to do both. The project that I'm giving you has a template. I will open it up so you guys can see on video what it looks like to download and start using this. Ignore my not paying for WinRAR. There's a different driver. Anyway, okay. So I've written a bunch of tests, and this is where the program runs. And then you also have your Dynarray template. The Dynarray template it already handles building the class for you. I know that was very hard to type some brackets and some words. But the other thing it does is it makes a bunch of arrays. Or not arrays, a bunch of functions in relation to the array. And I've written what they should do, but they don't do it right. I've made them able to compile, but none of them are correct. What your job is to do is simply to follow the instructions here, make the function do what it says, and then the program should run and it should pass. Every test should pass. It currently won't. In fact, I think it fails immediately on it doesn't even get to the point where it tells you that test one fails. It actually breaks. But that's once you're finished, I won't do that. So back to the assignment. You can make any additional functions, because I know if you have a different way of doing things than I would, you might like other functions. I don't think that's a bad idea. Please feel free to add them, or member variables, and even. And I put a hint here. The whole point is that this is an array. You'll probably need one or two arrays in your class somehow to deal with these things. The main thing, though, is that you cannot use list. List is a C# version of a dynamic array. It allows you to add and take away from the array, and then get a version of the array. You're basically making a bad version of list. If you use list to solve these problems, you're not solving the problems. You are just finding a way to have someone else solve it. Professionally, that's great. Do that at your job. But for learning, it takes away all your ability to figure this out on your own. At the bottom, there's a link that should be public to everybody. You should be able to access the zip file and download it. If you have issues opening the project, because some IDEs don't use solutions, you can import the CS files. You can open them in a text editor and copy them and put them in files that you've made inside your project. However you need to do it is fine. The important part is that you're going to hand me back the Dynarray CS file. I'm going to replace mine with it. I'm going to run it. If it passes, it passes. If it fails, it fails. There's no question about this. It's very easy for me to grade. And the same goes for you. Even if you want to change it, if you need to alter your program.cs file to help you debug issues that you might be having, feel free to. But ultimately, I'm not going to take your version of program. I'm taking my version of program, so it needs to pass with the original. If you guys have any questions, feel free to send them to Discord. It doesn't look like we have a lot of people on this stream, so it's not going to be a big deal to wait around. Good luck. I believe I set the due date for 2 years, or 2 weeks. So because this can be a really big one for beginners. Same thing. If you have issues, please go to help. It's better to ask me questions in front of everybody so we can all learn from it than it is for you to save your ego and ask it privately. And if I'm not available, other people might be able to step in and work on the problem with you. They might be able to figure out similar solutions. So that's it for this stream. I will catch you guys in 2 weeks. Good luck.